All right, let's dive right into this. Welcome back to another explainer breakdown. I'm your master inspector, and today we're tackling a super high-yield, deeply technical scenario for your 309A electrician exam. Listen, when you're out in the field dealing with high amperage feeds, you absolutely cannot afford to guess. I mean, we're talking about installations carrying so much current that they can literally melt surrounding metal if you get the physics wrong. The code is your ultimate blueprint here for safety, compliance, and frankly, just preventing catastrophic failures.
So, let's look at the exact question you might face on test day. Read this carefully. What is the requirement for installing single-conductor mineral insulated cables for a 600-amp, 600/347-volt, three-phase, four-wire feeder? Is it option A, spaced a minimum of 1 cable diameter apart? Or perhaps option B, installed to prevent the flow of sheath currents? Could it be option C, spaced a minimum of 190 millimeters apart? Or option D, grouped together to minimize induced sheath voltage? Take a real close look at those exact parameters. A 600-amp, three-phase, four-wire feeder utilizing single-conductor mineral insulated cables. That is some highly serious, heavy-duty current. And the physical installation is just absolutely critical to getting this right.
Okay, we're going to break down the code on this right now, but before we tear into the technical details, make sure you subscribe to get these daily explainer breakdowns right in your feed. If you want to get licensed and completely crush this exam, well, you need to understand the why behind the rules, right? So let's find the exact answer and see what the Canadian Electrical Code mandates for this specific setup.
Notice how we can immediately, and I mean aggressively, rule out options A and C. Both of these options suggest physically spacing the single-phase conductors apart from one another. Now listen closely to the physics happening here. When you have single conductors carrying a massive 600 amps of current, wow, they generate intense, highly dangerous magnetic fields. If you space them apart, you are completely failing to cancel out those expanding magnetic fields. As a result, the inductive reactance just goes through the roof. You effectively turn your raceways, your metal supports, and any surrounding ferrous metal into giant localized induction heaters. No joke, the metal gets violently hot. The code reality dictates that the influence of the magnetic fields from single conductors of adjacent phases must be neutralized to prevent this exact thermal hazard.
All right, let's move on to the next set of options and see how analyzing the nuanced difference between option B and option D really builds our deep understanding of the code. Option B talks about being installed to prevent the flow of sheath currents. Now, it is true that the code discusses using jacketed cables or specific targeted bonding techniques to prevent local sheath currents from flowing due to building structures. However, the physical installation arrangement of the cables themselves, meaning how they're physically routed and physically placed next to each other in the air, targets something else entirely. It targets the induced voltage on the sheath. Actually, option D hits the nail precisely on the head regarding the physical arrangement of these specific high-amperage cables.
And this brilliantly illustrates the absolute indisputable authority on the matter. Let's bring down the hammer with the exact text straight from the Canadian Electrical Code. Rule 4-008, Sub-Rule 7 clearly states, where single-conductor mineral-insulated cables are used, all current-carrying conductors shall be grouped together to minimize induced voltage on the sheath. There's zero ambiguity here, guys. When you use single-conductor MI cables, grouping them is a strict, undeniable, mandatory requirement to manage that dangerous induced voltage.
So, the crucial point here is knowing exactly where to look when the clock is mercilessly ticking down on exam day. Here's your Master Inspector pro tip for rapidly navigating the codebook under the grueling pressure of the 309A exam. Section 4 covers conductor installations. Whenever an exam question targets the physical arrangement, the spacing, or the grouping of high-amperage single-conductor feeds to manage inductive reactance, always lock into Section 4 immediately. Do not waste your precious time flipping blindly through grounding sections or general equipment rules. Know your sections, save your time, and secure those points.
Let's go back to our options. Knowing what we now know directly from the text of Rule 4008 Sub-Rule 7, we can confidently eliminate spacing them apart. And we know that while preventing sheath currents is an important factor in general cable selection, the physical requirement for the layout itself is grouping. Therefore, the correct answer is absolutely option D, group together to minimize induced sheath voltage. By grouping them tight, you ensure that the magnetic fields of all the single conductors in each phase, along with the neutral, perfectly and completely neutralize each other. It's elegant physics, mandated by strict safety code.
Listen, do not leave your hard-earned license to chance. Getting these critical nuances right is what truly separates an apprentice from a fully licensed master journeyman.
For full 309A prep courses and hundreds of practice examples exactly like this one, head over to averdash.com. But before you go, I want you to ask yourself this. If a simple grouping mistake on a 600 amp feed can turn your metal raceways into a massive induction heater, what other invisible hazards are hiding in your everyday electrical installations? Think about that next time you pull wire. Get it done right the first time, and I'll see you out in the field.
For more sample question, follow us.